In this video, we will study Booth's algorithm. Booth's algorithm performs multiplication of two signed numbers in iterative steps. For each iteration, the operation to be performed is decided by examining each pair of two consecutive bits from the multiplier. The register structure used for Booth's algorithm is as follows. The multiplicand is stored in register M. Let's consider 4 cross 4 multiplier. So we have multiplicand of 4 bits and multiplier also of 4 bits. The actual register which is going to be updated in each iteration is given by accumulator, then Q and Q minus 1. Now accumulator has the same size as that of multiplier and it is initialized to 0. The Q contains the multiplier value and the Q minus 1 is the extra bit appended at the right of multiplier for the bit pair recording purpose and which is initialized to 0. Now in each iteration we examine these two bits and depending on the values of these two bits we decide what operation is to be performed on this entire register structure. So let's see how the mapping is done. So we have Q0 and Q minus 1 and operation. For 0 0 the operation is only shift. For 0 1 we have add plus shift. For 1 0 we have subtract and shift. For 1 1 again we have only shift operation. So for add and shift I mean we have to add m to the accumulator. The addition, this is the operation, and for subtraction a is equal to a minus m. So basically it is equivalent to adding 2's complement of m to the a. You must know that for shifting entire register structure is shifted to the right. So all the operations are a right shift and this entire a, q and q minus 1 is shifted to the right by 1 bit. Now let's see the flowchart for the algorithm and one example to understand it better. So here you can see the flowchart for the Booth's algorithm and you can go through it quickly and see what operations are performed during each iterations. One thing to note here is that the shift operation which we are going to use in Booth's algorithm is going to be the arithmetic shift operation. So while shifting right any number, we have to maintain the sign of that number. For example, let's say we want to shift 1100. While performing right shift, the answer is going to be 1110. So that's why the sign of the previous number is maintained in a shifted number. So now let's take one example and see how Booth's algorithm works. Let's take minus 5 into minus 7. Let's initialize the values. Multiplicand is minus 5. It is 1011. Multiplier is equal to minus 7, which is 1001. Let's just note down the value for minus m in case we need it. That is minus m is 2's complement of multiplier, that is 010. Okay. So now we have these values. Let's write the register structure that we use. We use accumulator in q and q minus 1. Yeah, let's initialize this structure. A is initialized to 0 0 0 0. Then q is initialized to the multiplier and q minus 1 is initialized to 0. So this initialization step is complete now. Now in the first iteration we are going to observe the q0 and q minus 1 values. For 1 0 we know that the subtraction is to be performed. That is nothing but adding 2's complement of m to the a. So a minus m is to be performed. We are adding 0 and 0 1 here. In the first iteration we get a 0 1 0 1, q and q minus 1 as before. Now we perform right shift operation, that is maintaining the sign. First iteration is complete. Now second iteration, again we observe q0 and q1. This is 0 1 this time. So we have to add m to the a. So we add 1 0 1 1 here. Then we get 1 1 0 1. This remains same. Then we perform shift operation. Now note here the sign is 1. So we have to maintain that sign while shifting it to the right. You have to be very careful about these shift operations. Make sure you maintain sign every time. Okay, so here this is complete. Now again we examine these two bits for third iteration. This time they are 0 0. So there is no need to perform any addition or subtraction. We perform only shift. Again it is sign shift. So arithmetic shift, we do it. And for the final time, fourth iteration, we again examine these two bits. These are 1, 0, so we have to perform a minus m, that is adding 2's complement of multiplier. We add this, and the carry you can discard 0, 1, 1, 1. And now for the final time, we are performing, this is the fourth iteration going on, and we have to perform the shift for the final time, maintaining the sign, performing shift operation. That's it, the algorithm is complete. And now where is the answer? The answer is a and q combined. So this is the answer we are getting, 1, 0, 0, 0, 1, 1. You have to discard the q minus 1 term, and the answer lies in a and q, which is equal to, we can see it is 35, the answer expected. So I hope you have understood how the Booth's algorithm works and will be able to perform the sign multiplication using the same. Thank you.